Okay guys, this is the last lesson in the bonding unit. The only lesson we're going to have after this is a review unit, and I will put that up sometime over Thanksgiving break. So this last lesson is, now that we know how things bond ionically and covalently, we are going to take a look at the intermolecular forces that occur between molecules, not within molecules. Remember, intermolecular forces, we have inter, which means between. We have interstates that run between states, and then we have intrastates, which are highways that run within the state. So we're basically looking at the highways that run between states, but we're going to be looking at the forces that are between molecules. And there are three types of forces we're going to discuss: London dispersion, dipole-dipole, and hydrogen bonds. Only in covalent molecules, first of all, is what I want to say. Intermolecular forces are not in ionic compounds. And these are weak forces that act between molecules. That hold molecules to each other. And these intermolecular forces only exist in the gaseous and liquid states. They're called weak forces because they're much weaker than chemical bonds. Chemical bonds are the bonds that hold atoms together within the molecule. Remember, and we refer to intermolecular forces as IMFs. Remember, IMFs occur between molecules, whereas bonding occurs within molecules. And this is really important. Students have a hard time understanding the difference between the two. I'm going to explain here. We have HCl, and we know that Cl has 7 valence electrons. And we know that hydrogen comes in here with its 1. So these 2 electrons are represented by this bond line. This is a covalent bond, and it is, to be more specific, this is a polar covalent bond. Why? Because the chlorine has a higher electronegativity than the H. So there is going to be a dipole moment in this direction. The chlorine side will be slightly negative, and the hydrogen side will be slightly positive. So what happens when I get a bunch of HCl's in a beaker? So say I have hydrochloric acid, which is a liquid, and I put them all in a beaker. So now I have all these HCl molecules. What's going to happen is that the molecules will align themselves so that the positive of one and the negative of another will be attracted to one another. And this is the intermolecular force that we are talking about. Please remember, again, IMFs are not bonds. They are between molecules, just as we just saw with the 2 HCl's. Okay, let's look at the first type of intermolecular force, London dispersion forces, better known as LDFs. These are the weakest of the 3 that we're going to discuss, and they really are only important for non-polar molecules. The more electrons something has, the greater the LDFs. And what happens is the electron-electron repulsion creates brief dipoles in atoms or molecules. So first of all, let me give you two examples. So the London dispersion forces between I2 would be greater than that of Cl2. Why? Because I2 has more electrons than Cl2. So if there's more electrons, there's more electron-electron repulsion, which creates these brief dipoles. I'm going to show you a short video of this.
Electrons in an atom are in constant motion, but at some point in time there are more electrons on one side, creating delta negative and delta positive charges, or an instantaneous dipole. The instantaneous dipole on one atom can induce an instantaneous dipole on another atom, and they are oriented to cause an attractive force. Later, the electrons on both atoms have moved, but they tend to move together to preserve the attractive force.
Okay, so what they were showing you there was the neon, the electrons are constantly moving. And as when they're constantly moving, sometimes more electrons wind up on one side of the atom than the other, which means that you're going to have a slightly negative charge on one side and a slightly positive charge on another. And that can cause a temporary dipole in another nonpolar molecule. And it's these temporary dipoles that cause the molecules to be attracted to one another and create this very, very weak intermolecular force or attraction. All right, let's look at the next one. Dipole-dipole is exactly what I just showed you with the HCl. Molecules such as HCl have both a positive and a negative end, or poles, and two poles equal a dipole, because di means two. This results from an unequal sharing of electrons, and the shape is usually asymmetrical, meaning you cannot fold it in half and have a mirror image of the molecule. Dipole-dipole is two molecules with permanent dipoles that are attracted to one another, kind of like the two HCl's that I just showed you. One HCl that had a dipole, slightly positive side by the H, slightly negative side by the Cl, and that was attracted to another dipole in another HCl molecule. So the two molecules with permanent dipoles are attracted to one another temporarily. A dipole moment is a measure of the strength of the dipole within a molecule, or its polarity. We usually do this by looking at the electronegativity difference. And here we just said it. The greater the difference in electronegativity between atoms, the greater the dipole. The higher the dipole moment, the stronger the intermolecular force. So for example, if we look at HF versus HCl, HF is going to have a stronger intermolecular force than HCl between its molecules because the electronegativity difference, the ED in HF, is greater than the ED in HCl. So we're going to look at an example of this now. Let's take a look at the last one. Take a look at dipole-dipole attractive forces now. So here you have two polar molecules. They both have a dipole because one element has a higher electronegativity than the other element. So one side of the molecule becomes slightly negative while the other becomes slightly positive. And what happens is that these molecules will position themselves so that a positive and a negative end are attracted to one another. And this is called the dipole-dipole attraction, or the dipole-dipole intermolecular force. This is the intermolecular attraction, the dipole-dipole attraction between the positive end of one molecule and the negative end of another. And let's take a look at the last one now. Hydrogen bonds are a specific type of dipole interaction. In a polar bond, hydrogen is basically reduced to a bare proton with almost no atomic radius. This is the strongest of all IMFs by far. And the thing is, it only occurs with hydrogen and 3 other molecules. So hydrogen bonds occur when H bonds to, I say, NOF, nitrogen, oxygen, or fluorine. And let's take a look at that. So here's the water molecule. We know that the oxygen side is slightly negative, the hydrogen side is slightly positive. This allows water to hydrogen bond with other water molecules. This is very similar to dipole-dipole. Hydrogen bonding is a special type of dipole because it only happens when hydrogen bonds to NOF, nitrogen, oxygen, or fluorine. So here, the hydrogen of one water molecule is attracted to the oxygen side of another water molecule, and it forms this network. Okay, so we have 3 types of forces. Well, remember, intermolecular forces occur between molecules. We have LDFs, which are London dispersion forces. These occur in nonpolar molecules. And temporary dipoles are created by the moving electrons. And what you need to remember is that more electrons, the greater the LDF. Then we have dipole-dipole, and this usually occurs between polar molecules. And then we have the last one that we just did, hydrogen bond. And that occurs when H bonds to NOF. So if we had to rank these in strength, this is number 1, this is number 2, and this is number 3. So this would be strongest to weakest. Okay, and that's it. Enjoy the rest of the weekend.